That is tension in terms of A, mg and x. Let's have a look at what we're being asked to do in part B. The horizontal component of the force exerted by the wall on the pole is 9 mg. 9 mg over 2, sorry. So the horizontal component of the force exerted by the wall on the pole is 9 mg. So what that means is, if I go back to here, the force exerted by the wall on the pole is 9 mg, which means that, lost my train of thought. Oh, it's okay. What that means is that 9 mg must be equal to the horizontal component of this thrust, which, if that's t sine alpha, would be t cos alpha. So what that means in part B is that t cos alpha equals 9 mg over 2. Now I know that cos alpha is 3/5, so I'm going to replace that with 3/5 and say that 3/5 t is 9 mg over 2, which means dividing by 3/5 that t is 7.5 mg. So I now have t as a value. I can equate that with this equation that I found out in part A, and hopefully resolve through to find some information about x. So 75 mg minus 10 mgx over 8a is equal to 7.5 mg. Multiply it by 8a, I'd have 75 mg minus 10 mgx equaling 60 mg. And at this stage I can cancel m from all three terms, and I can cancel g from all three terms. Which means that I have 75a minus 10x equaling 60a, which means that 10x must equal 15a, and that x is therefore 3 over 2a dividing 15 by 10. So I was given the horizontal component of the force. I equated that with t cos alpha, because that was the force acting horizontally from this thrust, and I therefore worked out from that what t was. I could equate it with what I had in part A, and now I know that x is 3 over 2a. Last bit. C, the vertical component in terms of mg of the force exerted by the wall on the pole. So, got the horizontal component, we're now looking at the vertical component. So, let's go back up to our diagram. And what we need to consider is that all the forces acting up will be equal to all the forces acting down. Because what we're trying to find is the reaction here at y. So first of all, up I've got t sine alpha. And then acting down, I've got reaction y, mg to mg. Right then, let's fill in what I know. Let's just review. We worked out in part B that T is 7.5 mg. So let's put that in, 7.5 mg. Sine alpha we worked out at the beginning was 4/5. Let's put that in. Equals the reaction at y plus 3 mg, which is just 1 mg and 2 mg. Right. 4/5 of 7.5 is 6 mg, which is equal to the reaction at y plus 3 mg. And subtracting that 3 mg, I get the vertical component to be 3 mg. So, things to consider then. With this one, because the rod was pushing up on the plank, we had a thrust rather than a tension. We also had to consider, because it was hinged, that there would be a horizontal and a vertical component of the reaction in the hinge. It's not ideal, but actually, if you end up drawing those two arrows in the wrong direction, it would be okay. Because what you would do is you would get to here, and if you had Ry on the wrong side of the equation, you would end up with Ry equals negative 3 mg. And as long as you were confident in everything else you would have done, you could say, right, the fact that I've got the reaction to be negative means that the direction I've assumed it's going is actually opposite. It's a little bit of a fudge, you might think it's a little bit cheating, but as long as you're confident in how you've set everything else up and that you've got all the forces considered, that is an explanation of why you might end up with a negative reaction force on a hinge question, given that these are, as I said at the very beginning, proper gangster. There we go, job done.